Okay, so vectors and scalars. Now I'm pretty sure that most of you know or have some idea as to what vectors and scalars are, right? We know that most of the physical quantities out there can be either categorized as vectors or scalars. But there are certain quantities, and you will see those quantities in this class, which are neither vectors nor scalars. So if you already know what a stress is, what a strain is, you know that it is actually not a vector or a scalar. It is what we call a tensor quantity. Okay, so when you take strength of materials class, you will learn about different kinds of stresses, but you will learn about at least some kinds of stresses in this class as well. Scalars, you know, require a specification of just one number, which we call magnitude, right? And we have multiple examples of those. We have some things like mass. If you want to specify the mass of an object, you can say the mass of this object is 5 kilogram or 5 pound mass or 5 slugs, and you're just giving one number to specify that quantity, right? Similarly, you have things like volume, area, density, work, energy, pressure, distance. All of these are what are known as scalar quantities, because specifying them requires just specification of one number along with a unit if it is a dimensional quantity. If it is not a dimensional quantity, then it has no units in. Vectors, on the other hand, require specification of two things. One is a number, which is the magnitude, and the other is the direction. Okay, and some of the physical quantities naturally have both the information. So when we talk about, you know, velocity, right? I say I'm driving my car on Long Island Expressway at 55 miles an hour. To truly tell the velocity vector information, I have to also say something about which direction I'm going in. So I might say I'm going in the direction of New York City, okay, at any given instant. So as long as I specify both the speed, which is the magnitude part of the velocity, and the direction I'm going in, I have specified the full vector quantity. If I don't specify one of them, then I'm not specified the full vector quantity. So velocity is one example. Acceleration is, of course, another vector, because acceleration is obtained as the derivative of velocity. So those of you who are taking calculus already know what a derivative of a quantity is. You have force, which is also a vector quantity because it requires both direction and magnitude. Moment, which we'll talk about. Displacement should not be confused with the distance travel. Distance travel is a scalar quantity. Displacement has information about what the magnitude is as well as the direction of the displacement. Okay, and you know, momentum, angular momentum, linear momentum. There are lots of quantities that can be classified as vectors.